Okay. 4.8. Triangle proportionality theorem and using proportional relationships. So first thing is first, I'm the realist. Second thing,
I'm the realist. I'm the realist.
as long as you acknowledge
Hey, you gotta shake my hand because I did it.
I did it too.
Okay.
You didn't even say it.
Did I ask your opinion?
Respect the lane. Okay. Hey, so triangle.
What is the lane?
The lane, the disco.
Cafe
disco.
Alright, so like a disco
Dude,
cafe.
imagine that.
No, completely different.
But then you just spend the rest of the day at cafe disco.
Okay, voices back off, please and thank you. Triangle proportionality theorem says if a line parallel to a side of a triangle intersects the other two sides, then it divides those sides proportionally. Let's look at this, break it down, what it means, okay? So if a line, okay, line EF right now, if a line parallel to a side of a triangle, line EF, you might not be able to see it very well, but it shows that it's parallel to the side BC, and it says that right down here as well. Okay, so if a line parallel to a side of a triangle intersects the other two sides, it intersects the other two sides. So far, this fits all the qualifications of this if, right? We have an if-then statement. You guys remember if-then statements? This fits all the qualifications of the if, so it means the then is true. It divides these sides proportionally. So it divides AE and the side AB and AC proportionally. So at the side above, AE over EB is the same ratio as AF over FC. It's kind of weird, but as we get into using it, I think it'll make more sense to us. So let's go ahead and do this first example on letter A. We need to find the length of each segment. So first, if a line parallel to a side of a triangle intersects the other two sides, we have a line XY parallel to a side of the triangle BC intersecting the two sides, the other two sides. So it fits all the F part. So we know that then will be true. We know that then will be true because it fits all the qualifications of the if part. A line parallel to the side of the triangle, and it intersects these other two sides. So it'll divide these two sides proportionally. So we know up here it was AE over EB. For this triangle, that would kind of be like 9 over what number? 4. Okay, so if we had AE over EB, AE over EB, for this triangle, that would kind of be like 9 over 4, AX over XB. And we're saying that's going to be equal to, on the other side, AF over FC, AF over FC would be like what? 10 over X. We don't know what this is, so we can call it X, we can call it A, we can call it B, whatever we want, we can call it. Okay? You could even call it smiley face or question mark. That's fine by me. Okay, just keep it appropriate, you know? And so now, how do we solve the proportion? We have proportion, we need to find the side. Cross multiply. We cross multiply. 9 times X is what? 9X. Okay. 4 times 10 is 40. 9X is equal to 40. How do we solve for X? Divide by 9. X is equal to 40 divided by 9. Oh, that doesn't work out very well. That's a shame. Okay. 4.44 repeats. But it ends up being 4.4 repeatings. X is 40 over 9. 4X is exactly 4.4 repeating as well. So on the exact, the other repeating. If you don't have the repeating, you would need to put approximately 4.4 and then you round it. Now you can leave your answer as a decimal, as the approximation, rounded to anything it specifies. If it doesn't specify, just round to the 10th. Or the fraction, or the round, or the exact one with the repeating one.
Oh, so we could just keep it at like the
This, or this could work. Actually, no, I changed my mind. I want the decimal. I want the decimal.
Come on, you got my hopes up.
That's good.
Why did you?
Why did I change my mind?
No. What's up with the bottom?
This is X is about. This means approximately. Because it's like, it's equal, but it's not sure, so it's shaking on its way there.
Like Mr. Combo of
Yeah, right? It's not too confident. Thank you. I was like, I'm like, it's a pretty clever one. I was like, happy with it. Came with it on the spot too. Like, that's good. Okay. Hey, so welcome to geometry class. Hey, what's an acorn say when it grows up? The acorn. What's it say when it grows up? G. I'm a tree.
Is that the Mr. Titus?
Yeah, I got it from Mr. Titus.
Yeah.
Okay, real talk. Okay, first day of school, Mr. Titus comes in here, and he comes into one of my geometry classes, and he says that joke. And he's, we came in for 2 different classes. So I think this was the second one. He came in for 2 different classes. One class he comes and says it in 5th hour. Okay, he came in the 5th hour in this hour. So he came in and he said it so quickly that I don't know what he said. I don't like it's a joke. He's like, "What's an acorn say when it grows up?" Geometry. And I'm like, and then he comes in and says it again, and I'm like, G, I'm a tree. I'm like, oh, I understand now. G, I'm a tree.
Wait, I don't get it.
Acorns grow into trees.
What class are we in?
We're in
It's a pond.
Yeah.
G, I'm a tree.
Hi, tree. I'm
G,
Jacob.
I'm
Nice
a
to meet
tree.
you.
Oh!
Oh.
Okay, hey, let's go on to B.
Alright.
Let's go on to B.
Were you not here when he told us?
Once again, if a line parallel to a side of a triangle intersects the other 2 sides, do we have this set up here? Yes, we have a line parallel to the others, to a side of the triangle intersecting the other 2 sides. You can also just kind of look at it and say, we have 2 lines parallel, and one is the side of the triangle. That's really kind of what we need to know, okay? As long as the other side's like not like out here or something like that, because that would help us. Right? Okay. Hey, who can tell me how we can set this up?
I got you.
Okay, Aubrey.
Okay, so you're gonna do 5 over 2. And then you're gonna do x over 3.
And these are going to be equal to each other. This would be a good setup. We could do 5 over 2 equal to x over 3. Yeah.
Does it matter which way I set it up?
We'll talk about that after we solve it. But I like it. So let's cross multiply. 5 times 3 is?
2. Wait.
2 times x is
42.
2x. Divide by 2, divide by 2. X is equal to?
7.5.
That's a super fast.
Okay.
What this class is.
Aubrey got a good question. Hey, Mr. Gossel. Doesn't matter how I set it up. She set it up 5 over 2 is equal to x over 3. What if we had set it up as 2 over 5 is equal to 3 over x? Well, let's try it.
Oh, wait,
Cross
it doesn't
multiply.
matter. Look at
2x is equal to 15. Are we going to get the same thing?
No, you might get 66.
No.
What?
It's the same thing.
Okay.
Hi, joking. I'm Jacob. Nice to meet you.
What? What? Looks like I have a Bobby
How
Brown.
much candy do you have?
I can sit here all day.
Okay. Anyway.
Oh, that's why you were doing it for one day. Just like
Alright. Hey, let's also explore something else here, class. Let's explore something else.
We're not gonna go around the halls again, right?
No.
Oh, Andy. We do that every class. Can we get bucket hats ready?
Oh, I am.
Actually,
I remember making.
we're gonna do one to two more examples. Probably this one. Hey.
There are no more examples except for a new thing, and I'm not
Exactly.
gonna remember that.
That's okay. So, triangle proportionality theorem was an if-then statement, right?
No.
Hey, when we have if-then statements, can we also flip it around? What's that called?
Then it.
Converse. Converse of the triangle proportionality theorem. If a line divides the 2 sides of a triangle proportionally, it is parallel to the 3rd side. So we're saying if this line EF divides AB and AC, the sides proportionally, then we know they're parallel. We're going reverse. Instead of saying it's parallel, so it divides the sides proportionally, we're saying it divides the sides proportionally. Now it's parallel. Don't be starting at right now. That's not even. Okay. So just making sure. Okay. So let's try this one out as well. So if we verify that MN is parallel to KL, we're trying to prove it in a way. How would we set that up? What would be true if this is parallel?
Oh wait, the things would set. The things would make this thing do 30 or 50 equal 42 over 21. So then, yeah. What did you put question mark?
Okay, so I'm gonna talk through all of this that just happened.
Alright,
Did you like?
Okay, so what happened was we said, hey, if these two lines are going to be parallel, then these two sides need to be cut proportionally. According to this converse, if these two sides were cut proportionally by this line, then these two lines are parallel. So we say, okay, before, on the last slide, we did 9 over 4 and like 10 over x. So now we'll do 30 over 15 and 42 over 21. And we'll check it. And I put a question mark there saying, is it equal? Because we don't know it's equal yet. We're trying to see if they are. Because if they are equal, then these are parallel. If they're not parallel. I just spit a little bit. If they're not parallel. It didn't get on anybody though. So didn't go that far. So we say question mark, is it equal? Like it equals it? Maybe? Okay. So then we figured out, okay, 30 divided by 15 is 2. 42 divided by 21 is 2. So they are equal, thus making these two sides, or these two lines, parallel. Does that make more sense?
Yes.
We kind of broke it down that way. Okay, I also want to look at something, bless you, we don't ask, bless we forget. Last thing we're going to look at is still on this problem. Okay, still on this problem. So we said we can either do 30 over 15, or like, and 42 over 21, or we could also do like 15 over 30 and 21 over 42, right? We said we can reverse that. As long as we flip one, we have to flip the other.
Yeah.
Could we also do, say, I don't know, 15, this is part of it, over the whole side 45, and 21 over the whole side 63? They would end up being the same thing. They both reduce to a third.
How would you do that?
So we have a variety of things we could do. You can incorporate the whole sides if you want. What we have to be careful with, class, what I want you to take away from this part, this little side discussion in the blue, what I want you to take away from this part is whenever we do these with the trying to prove lines parallel or if lines are parallel, we need to be consistent in our proportions. So if we do the top part and then the bottom, we have to do the top and then the bottom. If we do just the bottom part and the whole thing, we have to do the bottom part and the whole thing. We have to stay consistent. Okay? No new homework. It's just that 4.7. Okay? That's all the notes for this. And we're done for the day. So that 4.7 is due when?
Too soon.
Friday, next class.
Block. Tomorrow block.
Okay.
Tomorrow.
Class, Kaylee has a dad joke.
What is the green grape to the purple grape?
What? I don't know.
I don't know.
Breathe.